seeing some patterns here, okay? So, I lost that thing here. So since we're talking about binomials today, our focus is going to be all about on binomials. So if I gave you the binomial of x plus y and I raised that to the 0 power, what does that produce for an answer? 1. Very good. Very good. If I gave you x plus y and I raised it to the first power, what does that reveal for an answer? X plus y. You guys are on fire. Good. Now, x plus y to the second power. Don't say anything yet, because the answer is not x squared plus y squared. So don't be that person. Don't be that guy. Yes, Ethan, what is it?
Is it x squared plus xy, 2xy plus y squared?
Yeah, nice job. You got it. Okay, that is definitely it. I'm so glad that you did not ruin it. Okay. Okay, so we can keep going with this. Our goal today is to understand how to come up with x plus y to any power. That's our goal, all right? Now, do you notice? Ooh, Adrian, you hit it right on the head. Check it out. What's the exponent? What is the exponent here? How many terms was it produced? 1 term. What's the exponent here? How many terms produced? 2 terms produced. How many here? 1, 2, 3. 3 terms. So what's the moral of this story, ladies and gentlemen? If there are n,
It's n minus 1.
n plus 1 term. Good. We got it down. Good. Okay, cool. All right, great. So second idea of the day here, okay? Now, this is going to look a little strange, and there's 2 ways that we can count something. And we as human beings think that we're actually really good at counting, when in fact we stink at counting. We are actually very terrible at counting, okay? So, but there is one formula that we're going to be using, and it's how to choose something. And it looks kind of like this. N with a J and parentheses around it. There are 2 ways that we can represent this. One of the ways is like this, and the other way is this. N with a big giant C and then a J. Both of these things mean the same thing. When you see this, in your head you think n objects chosen j at a time. Okay, so both of these things mean that. N objects chosen j at a time. All right? Now, I don't expect you to understand this quite yet, but this is all set up into probability and the binomial theorem. Lots of setup. So let me do a little example with my... Okay, no, let the record show that there cannot be over 100 on this. Okay, so there's a formula that we can use to help us keep track of the things that we are counting, okay? So if we have NCR, or J, or I'm using R because that's what the calculator uses, or NJ, here's the formula that we're going to write down. Okay? It is N factorial, there's that factorial again, divided by J factorial times N minus J factorial. So this is important. This needs to go on a note card somewhere for your test in March, okay? That's important. So, here we go. Let's go to the third box and let's evaluate some of these, okay? We're going to do it right now. So we're going to do A and we're going to do B, and then we'll have a couple of side talks. So let's take 10, 3. And the highest bid that we had from 10 people choosing 3 at a time on the team was 99. So here's where let's plug this into our formula. We're going to have 10 factorial divided by 3 factorial multiplied by 10 minus 3 factorial. Now, I don't expect you to write this out the way I'm going to write it out every single time. You can use your calculator after you show me the formula that you know that it exists and knows how to use it, okay? So here's what we become. 10 factorial really means 10 times 9 times 8 times 7, and I'm going to stop right there at factorial. Does anybody know why I'm going to stop there at factorial? Because 10 minus 3 is 7, so there happens to be another factorial on the bottom, isn't there? So this is 3 factorial times 7 factorial. So that means my factorials go away, don't they? So really what I've got going on here is 10 times 9 times 8, all divided by 3 times 2 times 1, because that's what 3 factorial is. Now check this out. 9 divided 3 is 3, and 8 divided 2 is 4. So 10 times 3 is 30, times 4 is 120. There are 120 different teams that we can pick of 3. We could be here all day picking different teams of 3. So like I said before, human beings are not very good at counting. We think we are, if it's by ones. But when we start grouping things together, we are not very good at counting, okay? So let me show you how to find this on the calculator. So bring your calculators up, please. Okay, let's close this down. So what we're going to do is we're going to try and figure out 10, choose 3. And here's how it works. So calculator's on. We're going to have 10. Punch in 10. Hit the math button. If you move your cursor to the left, it brings up the PRB, which stands for probability. And you can look at option 3, which says NCR. Now, the calculator uses R's, the book uses J's, but they mean the same thing. N objects chosen R at a time, N objects chosen J at a time. So if you push just number 3, it brings up that choice in the list for you. And we want 10, choose 3. There it is, 120. Oh, yeah, clapping. Good. Applause. Good. There are 120 different teams we could make from 10 people choosing 3 of them, which seems crazy. And 100, 947. Correct. Okay, question to you. Back up to the 10, choose 3. Okay? If from my 10 people, I'm going to choose 3 of them, okay? Now I'm going to change my team from 3 people to 5 people. Would you expect my number of choices to go up or go down? Or stay the same?
I say down.
All right. Genius. I get it. Okay, so there are 2 special cases we need to talk about. All right, there are 2 special cases. And those special cases are, number 1 is n choose 0 is equal to 1. Because we just said there is one way to choose what?
Nothing.
To choose nothing. Did I spell choose right? No. That's chose. That's the past tense. Thank you. Yeah, that's not embarrassing. All right, and 2. N, choose N is also 1 because there is one way, I know, one way to choose everything. Okay, there's one way to choose nothing, there's one way to choose everything. And how do we get a 0 out of this formula then? What would it be? Because what's 0 factorial? 0. No, 0 factorial is defined to be 1, remember? That's why.
Well, 0 factorial minus 0 factorial.
So how would we get a 0 out of this thing? The ways of choosing. The only way that would happen is if there are more people or more choices than people. So if I had 10 people and I want to make a team of 12, that's 0 because you can't make a team of 12 of 10 people. So that's the only way you get 0 out of that thing. Okay. All right, here we go. Let's so deep. Okay. All right. So let's hear. I'm gonna give you the first couple of rows of Pascal's triangle, and I want you to see if you can identify the pattern. Please don't yell the pattern out. Just put your hand up if you can actually see the pattern going on here. So the first row of Pascal's triangle is a 1. Second row is 1, 1. Second row is 1, 2, 1. Third row is 1, 3, 3, 1. Anybody see the pattern? Put your hands up. 1, 2. Let the record show. 4 people see the pattern. Here's the next row. 1, 4, 6, 4, 1. Raise your hand up if you see the pattern. Put your hand in the air. Oh, only 2 people. We went down. Okay, I'll give you one more. The next row. 1, 5, 10, 10, 5, 1. Who's triangles, right? So check this out. I mean, you are right on the pattern. I mean, to get this 5, don't I add the 4 and the 1, and I have a triangle here? Right? To create this 3, don't I add the 1 and the 2, and I have a triangle here? To get this 1, don't I add the 1 and the 0, and don't I get a triangle there? Okay, so totally blown. Okay. All right. So now that we've had a whole lot of fun for discovering Pascal's triangle. We're now ready to talk about the binomial theorem. Okay? There was a whole lot of fun that we just had talking about the binomial theorem that we didn't get a chance to record, but that's okay. We're all really stoked now. Woo! All right. So I do not expect you to understand this. Okay. So when I have, because it looks so weird, imagine I gave this to you the first box. You guys would like got up and left. If I have x plus a and I'm raising it to the nth power, all right. The binomial theorem says that I'm allowed to, or this is how it turns out to be. It's going to be n choose 0 times the first term of my binomial, which happens to be x, raised to the nth power, times a, which is the second term of my binomial, raised to the 0 power. I know, I told you. All of this is the first term.
Isn't that always going to be 1?
Hold on. Yeah. You guys are smearing there. Okay, plus the next term will be n choose 1, x to the n minus 1, a to the 1. That's the second term. And you keep going like this until you get down to n choose n, x to the 0, a to the n. Now, obviously, that makes perfect sense. Obviously, right? Well, yeah. Now, there's a couple of things that we need to notice that I want to point out to you, okay? Number one is that, notice that we're starting with the exponent of n, and we go from n choose 0, n choose 1, all the way up to where n matches n. That's the first thing that you should notice. Second thing you should notice is this. We take our first term, and we raise it to our highest degree exponent, and then we decrease that exponent by 1 until we reach 0. And the third thing you should notice is the reverse. If we take the second term, we start at 0, and we go up until we reach n. Don't the colors help? Okay. Let's try an example together. Now imagine if that was the first box. It would have been like, what? No bueno. Okay, here we go. The directions are to expand the following. Okay, here it is. It's going to be x plus y all raised to the 6th power. Now we have a choice. We could go x plus y times 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 x plus y and be here till next Tuesday, factoring all that stuff out and making a big giant matrix and combining all like terms and getting our answer. Option number 1. Or option 2, we can use this cool, fancy, awesome, slick, rad binomial theorem and get it done all in one swoop. What do you guys want to do? Okay, let's do that one, right? Okay, first things first. What is my exponent?
6.
How many terms am I going to have?
5.
Oh, we forgot already. Let's go back up to box 1. I'm going to have n plus 1 terms, right? Okay, so please set up, please, you're not stupid. Please set up 7 lines. 1, 2, 3, 4, 5, 6, 7. Notice how wide my lines are. Okay? Each of these represents the terms. The first term, the second term, the third term, the fourth term, the fifth term, the... Okay, first thing, after we figure out that there are n plus 1 terms, so there's 7 terms, let's set up our choose, all right? And by that, I mean we're going to start at 6 choose 0 and work our way up. 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and lastly 6 choose 6, which makes up my 7th term. That's step 1. You guys with me so far? Step 2, we're going to take our x value, which is our first term, and raise it to the power of 6 and go down by 1 every time. X to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and finally x to the 0. You with me so far? Good. Now we take our second term, our y value, and we start from the opposite direction. Y to 0, y to the 1st, y squared, y to the third, y to the fourth, y to the fifth, and finally y to the sixth. It sure is, right? Now, what are we doing to each of these terms? Well, there's a plus sign between them, so we're adding all these terms together. But don't worry. All of this stuff right here, you guys, this is called the setup. Okay? That's what I call the setup. You have set up your problem for success. You have not missed anything, right? Then we have what I call the cleanup. Here's the cleanup. Now, what is 6 choose 0? That's going to be 1. What's 1 times x to the 6th? What's x to the 6th times y to the 0? So my first term is just x to the 6th. And I have cleaned up my first term. You get it, right? Okay, now, plus. What is 6 choose 1? 6, good. X to the 5th, y. I have cleaned up my second term. Ooh, that's not a highlighter. Yikes. Sorry, buddy. I have cleaned up my second term. Okay, third term. What's 6 choose 2? 12. No, it's 15, isn't it? 15, x to the 4th, y squared. I have now cleaned up my third term. Plus, what is 6 choose 3? Oh. 20. 20. X to the 3rd, y to the 3rd. I have now cleaned up my fourth term.
So is x to the 4th 15 too?
It sure is. You mean 6 choose 4? Yeah. Is 15x squared y to the 4th. There is a pattern here going on, right? And then I'm going to have plus 6x y to the 5th. And then finally, the last term is really simple. It's just y to the 6th. And, oh, applause, applause, applause. Subtraction, and I have a coefficient. That's right. All right, so I have two things that are different. The coefficient and the subtraction sign. Okay, so let's do this a little bit faster than last time. How many terms am I going to have total? 5. So here we go. 1, 2, 3, 4, and then I'm going to have 5 terms, okay? First, let's begin by taking our exponent and doing our choose. So that's going to be 4 choose 0, 4 choose 1, 4 choose 2, and 4 choose 3, and then lastly, 4 choose 4. Now, we already know what those numbers are because Pascal's triangle tells us right there. So look, 4 choose 0 is 1, 4 choose 1 is 4, 4 choose 2 is 6, and then all the way down, okay? So we can get those for ourselves later on. Next, the first term is 2x. It's all of 2x. So you need to raise all of 2x to the 4th. And so what do you think the mistake that most students make is? They don't make that 16x to the 4th. They make it 2x to the 4th. So then the next one is going to be 2x to the 3rd. The next one is 2x squared. And then 2x all to the 1st. And then finally 2x to the 0. Now, we all know that's 1. I'm just writing it in there for sake of keeping the pattern the same. And then lastly, I'll do green for you. This is going to be y to the 0, y to the 1st, y squared, y to the 3rd, and finally y to the 4th. Now, how do we take care of this minus sign in between here, right? All we do is we switch off. We start with plus, we go minus, and plus. That's it.
Wait,
You alternate signs because the first term is all positive. That's why. That's why. Okay, so again, this is what I call, this is the setup phase, right? This is the setup. So then we do the cleanup. Okay, now the cleanup is a little bit more challenging because we have to go, what's 4 choose 0? Well, that's 1. And then what's 1 times 2x to the 4th? Well, that's a grand total of 16x to the 4th. You guys good with that part? Okay, so then I'm done with that one. Now I move on. I'm going to have a minus sign. 4 choose 1 is 4. 2x to the 3rd is 8x to the 3rd times y. So I am not done cleaning that one up yet. I'm going to put a circle around it. I still have more to do, don't I?
Whoa. 32. X.
You got it. I'm just going to do it this way to illustrate the point. 4 choose 2 is 6, because I looked at Pascal's triangle. 2x to the fourth is 4x squared. And then I have a y squared, and I'm not done cleaning that one up yet either. So I'm not going to cross it off my list. Then I have a minus sign. 4 choose 3 is the same thing as 4 choose 1, which happens to be 4. And then times 2x times y to the third, and I'm not done with that one. But I am done with the last one because it's the easiest one. That's just y to the sixth. So I can cross that one off my list.
Y to the fourth.
Sorry about that. Thank you. Y to the fourth. Okay, and then the next phase, what I call the double cleanup, is 16x to the fourth minus 32x cubed y plus 24x squared y squared minus 8x y to the third plus y to the fourth, and that's your final answer. What do you guys think about that? Good. Applause, applause, applause. I like it. All right, let me stop.